Okay, so I'm just going to call today like notes 1.2b, more transformations. We had listed all the transformations yesterday in our notes and function notation, but we just kind of briefly talked about the stretches and shrinks, and I said I would say more about that tomorrow. So, vertical stretches and shrinks are actually pretty straightforward. So if you'll just remember about the vertical stretch or shrink, that's when you are multiplying the whole function by some scalar. Okay, so c times f of x. And we're going to look at some examples today. Think about like stretching things vertically. You're pulling on the y of the function, and so you want to multiply the y value by the number, and y is represented by f of x. So that's why function notation looks like it does. Oh, we did a, didn't we, yesterday? Sorry, pre-calculus does a c. We put an a right there. So we did a times f of x, okay? And if the number was bigger than 1, then it did what we thought, which was stretch the graph. Okay? And if the number is less than 1 but more than 0, it shrinks the graph because it pushes it down and it has nowhere to go but out. Okay? So it vertically shrinks it. So vertical stretch and shrink really follow along really nicely. The key piece that you'll see in our examples is you'll have to remember to do like vertically stretch or shrink the whole thing. And the whole thing may require a set of parentheses. So you might have to do distribution. Horizontal stretches and shrinks we mentioned yesterday. And we said instead of multiplying a outside of the function, we're going to multiply a inside with the x. Okay, so f of ax. And we said it's kind of the opposite of what you think. When the absolute value of a is between 0 and 1, when it's a small number, it actually stretches it horizontally. So that to me is the opposite of what I think it would do. Okay? And when the absolute value of a is greater than 1, it actually shrinks my graph. Okay? So we wrote these things in our notes yesterday. When you take it out of the equation or out of the function notation, you're going to horizontally stretch or shrink your graph by a factor that is the reciprocal of c. Oh, sorry, a. So this is another sort of like weird moment of horizontal stretch and shrink. First of all, big numbers shrink it, small numbers stretch it. Weird, not what I expect. Just the same way with the h value, it does the opposite of what I think it would do. Negative numbers move it right, and positive numbers move it left. And then when I'm describing the transformation, or I'm actually doing the transformation, a horizontal stretch or shrink is going to be, when I actually do it on the graph, it's going to be with a factor that is the reciprocal of whatever that a value is. So if I'm saying that I'm horizontally stretching because I see a 1/2 in my function, then it's stretched by a factor of 2, the reciprocal of 1/2. So I'm going to put some examples up here. I'll do a parent graph. Let's say we have the parent graph f of x equals the absolute value of x. And then let's say I give you a new function, g of x equals the absolute value of 3x. Since we see that inside with x we're multiplying by 3, we can tell that that's a horizontal stretch or shrink because it's like a times x, 3 times x. And then because the 3 is more than 1, it's actually a horizontal Remember, when it's more than 1, it shrinks it. This is the opposite. It makes it smaller when it's a big number. So we would say this is a horizontal shrink. And then we say by a factor of 1/3. Okay, so there's two things you have to remember. Big number shrink, small number stretch, use the reciprocal. So what that's saying is, suppose your picture was taking up this much space, and then you horizontally shrink it by a factor of 1/3. Okay? It's 1/3 of what it used to be. So now it's horizontally pushed in. Alright, and then I'll do another one. Suppose we had f of x equals x squared as our parent graph, and then I give you something like g of x equals, and I'll do 1/4 x squared. Sorry, my square on the outside. 1/4 x squared. Now, the parentheses here are really important because the parentheses are protecting the 1/4, and so that's in there with x, so that represents a horizontal stretch or shrink. And this would be a horizontal stretch. So it's just the reciprocal.
Oh, okay.
So horizontal stretch of 4. Right? So when you write it out, it's going to be different. It's going to look like the reciprocal. Alright, now, here's what your homework is going to ask you to do. So these are some examples like your homework. I'm going to do a couple with you and then let you talk about a couple with your groups, okay? So you can decide if you need to write down the bolded directions. I would guess you'd probably be okay in your notes if you just write down an example. So write down the function and then what the transformation is supposed to do. I would jot a few of these down so that you get some practice with it though. Okay. So f of x equals 2 times the quantity x minus 3 squared plus 4. And we want to do a vertical shrink by a factor of 1/4. Now, be very thoughtful, right? Horizontal is the one that's a little bit messy. It's the opposite of what we think, and we got to think about the reciprocal. Vertical is pretty straightforward. So this says a vertical shrink by a factor of 1/4. So with vertical, I'm going to be affecting my y value up and down. So I want to multiply my y by 1/4. In function notation, a vertical shrink of 1/4 just looks like 1/4 f of x. And then in my work, if I'm writing a new function g, I could write something like g of x equals, and then I have to do 1/4 times f of x, but I want to multiply it by all of f of x, and in mathematics to say all of something we use parentheses. So it is important on these problems when you're doing vertical stretches or shrinks to use a set of parentheses, because whatever you multiply by for vertical stretch or shrink has to multiply through all terms in the function. Now, in this particular problem, when I distribute that 1/4, I can multiply 1/4 by 2, which gives me 2/4 or 1/2. And because 2 is getting multiplied by this quantity x minus 3 squared, this is all one term. I would not continue to distribute into this x minus 3 squared. That's not a term of the function. Terms of the functions are things that are being added or subtracted with each other. So you have 2x minus 3 squared, and then you have a plus 4. So you have two terms. So you would just multiply by that number out in front, and then multiply to the thing that's being added or subtracted in the back. So 1/4 times 4 is 1. So we would have 1/2 x minus 3/4 squared plus 1. And that would be our new function. Are we okay with that? Does anybody have any questions, concerns? Okay. Don't get too crazy with the distribution on that, right? Just put it in front of the function. And then if there's any k value added or subtracted, you'll have to multiply by that too. Okay. I'll do one more. F of x equals the absolute value of x plus 5 minus 3. And we want to do a horizontal shrink by a factor of 1/2. So if we're horizontally shrinking by a factor of 1/2, in the equation that's going to look like a 2, because we're going to use the reciprocal. And it's horizontal, so instead of multiplying out in front, it's going to multiply inside with x. So in function notation, that would be f of 2x. And then I just do the work. So this would be g of x equals the absolute value of, put in front of x, 2x plus 5 minus 3. I don't have to worry about distribution when it's horizontal, so that's kind of nice. Okay. You guys try the next two with your groups. So give your group members time if they want to write down their original problems. Give them some time to jot those down. And then come up with some ideas for what your equation would look like for number 3 and number 4. And we'll come together and compare, do we agree or disagree?
Why is it the reciprocal and not a reciprocal? So only horizontal is the
See if you can come up with an equation, a new one for both.
That makes sense now. Okay.
Like 1 more minute, 2 more minutes, 0 more minutes, where are we at?
2 minutes.
Give you a couple more minutes. Vertical is very straightforward, yeah. The number that it is, it goes out front, distribute if you have things that are added or subtracted, like K value. Yeah, you can come in. I'll be here at 7:30, so if you have questions on that, yeah, but you don't have to retake that one, you're just gonna fix it.
Is this how you would set that?
Yeah, and you can simplify, right? So anytime you can simplify the equation, you should.
Okay, so we kind of understand 3 and 4, but I'm still confused about why and 3 is
Oh, because it's a horizontal structure shrink. So do you have your notes from yesterday?
Yeah.
So we wrote them down yesterday down here. Okay, anytime it's a vertical, you do A on the outside. When the vertical is affecting Y, Y is f of x. You want to multiply Y by that scalar versus a horizontal structure shrink. You're trying to affect x because it's horizontal, so you're gonna multiply the x, not the y.
Okay.
I got.
Okay, I have put up on the board just my function notations for number 3 and 4. So remember, be thoughtful because you can either multiply your stretch or shrink scalar in the front of the function or on the inside of the function with x. And how you decide where to put that scalar is based on if it's vertical or horizontal. So a vertical stretch is going to affect your y value because y's are up and down. So we want to multiply y by the 3, and y is f of x, so it should be on the outside, 3 times f of x. When you want to do a horizontal stretch or shrink, you're trying to affect the graph horizontally, and horizontally that's x. So you don't want to multiply y by a scalar, you want to multiply x by a scalar. Okay? And so we know that it's going to go inside with the x. We have to remember that horizontal stretch looks like the reciprocal of what it is in the equation, so we will multiply by the reciprocal 1/3 inside. So I feel like vertical is really straightforward, and maybe the horizontal is sort of that strange one where it's the reciprocal version. Okay? So then just do the work. When you're trying to do g of x here for number 3, you want to multiply the whole thing by 3, and the whole thing in math is parentheses, so the whole thing is x minus 4. If you can simplify, you should. And so we could distribute the 3 through x and 4, so we're going to get 3x minus 12. That's our new function. And then down below, when I'm doing my g of x here, remember, all you want to do is put that reciprocal in front of the x. So I start my function like normal. Where I see x, I'm going to write 1/3 x, but everything else is the same. Minus 1 squared plus 2. The only thing we want to change is the x. Grace.
Wait, never mind.
Okay. Anything else? All right. Now, one more thing that we want to discuss, and you don't have to write anything down on this slide. This is just to maybe illustrate something for you. There's the question of, does it matter what order the transformations come? Does anybody know the answer? It is a yes. Okay, so I'm going to illustrate 2 instances where switching up the order results in a different graph. Okay, so if I were doing, I'm going to call it f of x, I'll do the absolute value function. So that's the V-shaped function. Here's our parent graph. to vertically stretch it by 2, I would multiply all of the y values by 2. So normally the absolute value has a slope of like up 1 over 1, up 1 over 1. Well, if all of those up 1s got multiplied by 2, my new graph would have a side slope of 2 instead of 1. So this would be my vertical stretch. I pulled up and it got skinnier. And then I would take the graph and I would move it up 3. So my final graph, this point goes up 3. This point used to be at 1, 1, but when I stretched it, it's now at 1, 2. And then I got to move that up 3. And I do the same thing for this one at negative 1, 2. Move it up 3. And this is where my new graph is. Okay, so that's my graph. Versus, here's the absolute value. If I move it up 3 first, it's going to have the same side slope that it did before, which is up 1 over 1. And then, when I vertically stretch it, remember to vertically stretch is to multiply all of your y values by that number. So now if I stretch them by 2, I'm going to multiply all my y's by 2. This point right here is at 0, 3. The y is 3. So when I multiply that by 2, I get 6. So now my vertex is at 0, 6. This point was at 1, 4. When I multiply that by 3, I'm going to be at 1, 12. So that's somewhere up here. Same on the other side. And I get this graph right here. And so just looking at them, are my final graphs the same? No. So does order matter? The answer is yes. Now, actually, the answer is sometimes. Okay, so on a side note, if you're doing two transformations that affect the same direction of the graph, then order matters. So in this one, I'm going up and I'm stretching it vertically. Those things both happen to y, so order matters. If I were to stretch vertically and move left or right, order wouldn't matter. To be on the safe side on these next problems, when they tell you to do one thing followed by another, my advice to you is do one at a time. If order matters, then you've got it covered. If order doesn't matter, it's still okay. But as opposed to sometimes trying to do too much at once, do one thing at a time, and then you should be okay. So we'll look at some examples. You'll have some like this on your homework as well. So kind of the same thing, actually a little bit simpler to start off with. I'm going to start with the parent graph f of x equals the absolute value of x. So really basic, parent graph. We're going to do two transformations. Translate it 2 units up, followed by a vertical stretch of 4. Okay, so followed by is the key word here. Order is going to matter in this case because I'm going up and stretching. Okay, so it says write a function g. I'm actually going to end up writing a function h just because I'm going to do one thing at a time. So I'm going to do g of x, and I'm going to do the first thing, which is 2 units up. That would just be the absolute value of x plus 2. Okay, so I got that one covered. And now I'm going to vertically stretch it by 4. So vertical stretch is the whole thing. So I'm going to call this one h of x because it's a new function. And I'm going to take the whole thing and multiply it by 4. So when I multiply the whole thing by 4, I'll distribute it, and I'll get 4 times the absolute value of x plus 8. If I had done that in the opposite order, if I had multiplied by 4, I would have had 4 absolute value x, and then I would have just added 2 and been done. Okay, so that would be a different equation. We'll do one more. F of x equals x squared. We're going to translate it 1 left, and then horizontally shrink by a factor of 3. Okay, left, horizontal, same direction, order matters. So I'm going to do one at a time. G of x equals what would it look like to say 1 unit left? X plus 1, quantity squared, very good, thank you. To say h of x, we now need to shrink it by a factor of 3 horizontally. We're going to do what? A 1/3 on the inside next to x. Questions, concerns? All right, so just think about that. I would recommend one at a time. That way, when you're taking a quiz, when's your first quiz? Anybody got their gold sheet out? When is that chapter 1 quiz? The 31st. So is that next Friday? Okay, next Friday is the chapter 1 quiz, all right? So on the quiz, if I ask you to do more than one transformation, you'll want to do one at a time in case order matters, right?
Regarding tonight's homework.
Oh, yeah.
Do you want us to do it on the back of the page?
Yes, actually, I'm so glad you asked me this. Yeah, so yesterday on the gold sheet, I had you cross off 17 through 45 or whatever that is. So tonight, you should have already done 3 through 16, so you're starting at 17. If you want to continue it on or do it on the back side or off, I know like most people have one column. If you want to do it on the next column, that's fine. But side note, I am going to pick up your homework tomorrow. So make sure that you do it on something that you're willing to tear out and hand it to me. So I am going to pick up and look at your homework tomorrow. Some days we'll pick it up and look at it. Some days we won't. It just depends, okay? Russian roulette. Okay. And reminder that summer packet quiz, you have that in your possession. You should be working on the corrections. And if you need some assistance, email me. Stop in before after school. Do not wait until the last minute. If you come in 2:30 on Friday and walk up to me, I had a question, that's too late. Your question needs to be asked before the beginning of class.